Okay, here we are looking at algebra notes for 4-14, linear piecewise equations, and we're taking a look at example number 1 here. So example number 1 here, we're going to make a table for our first step. We're going to make a table using each piece of this equation or this function that we're given here. Function, aka equation. For now, those are the same thing for you. So you can see here we have two pieces to this equation. We have a piece that is this, and then we have the secondary piece. Making a note of this right here. These pieces are the equation parts, and these pieces tell us when to use them. So this is saying, if you read this, this says that y equals 2x minus 3 for x's that are less than or equal to 1. On the other side, or underneath it, it says y equals negative 2/3 x plus 2 for x's that are greater than 1. You're always going to have that overlap with those pieces there. Okay, so two pieces, two different tables, and I'm also going to color code those tables with matching colors. I've got green and blue here. So my first equation, I'm just going to rewrite that y equals coming from right here, 2x minus 3. And I'm just going to make a table with x's and y's. Based on, and I guess I can set up the other table too while I'm at it, mine as well, negative 2/3 x. And again, these little things I do are just to prevent minor mistakes from happening. Okay, we've got tables set up. Start and end these tables with the given intervals, those x values. Those are those rules when to use them. So my blue equation says that I'm using 2x minus 3 for x's that are less than or equal to 1, which means I'm going to start my table at 1. The next table value, I need to make sure it follows this rule. So it needs to be less than or equal to 1. The next number that is less than or equal to 1 would be 0, followed by negative 1, negative 2, negative 3. Does it tell you when to stop? It doesn't. It just gives you a starting value. So start, no stop, which means you're going to have an arrow at one end only. And to show that here, I kind of draw an arrow at the end of my table. So I remember to put that in there. Negative 3, negative 4, dot, dot, dot. Okay. Now, looking at my other table here. My green equation says x's that are greater than 1. Now, when you think you might have to start with 2, because 1's not greater than 1, 1 is actually where we need to start. But notice, because of that, and I'm actually just going to scooch this table over a smidge. Because of this inequality, not an or equal to, this is going to have an open circle. Whereas this one with the line is going to be a closed. So that means, and I always like to highlight these, at my blue equation, this is going to be a closed circle, and so will everything else. Excuse me. And then at this green equation, this one value is actually going to be, oh, sorry, I wanted the green highlight. Got to keep it consistent. This is actually going to be an open circle here. I always like to make those notes because I'm less likely to forget it if I can see it right in the table. Okay, so continuing to fill in my table. So 1, x's that are greater than 1. 1, 2, 3, 4, 5, 6, 7. Again, no stopping point, so we have an arrow at that end as well. Okay, and again, so the reason we're starting at 1 here is because even though true, 1 is not greater than 1, that's why it's an open circle, 1.1 is greater than 1. And if I start the graph at 2, I'm missing all of those decimal values in between. I'm missing the 1.1, the 1.2, the 1.3, the 1.4, the 1.0000001. So we've got to start to have that little bit of overlap. All right, so to get your next step, we're on, we made notes of open and closed circles. So we're filling in the tables using our equations and or the calculator. Yes, oops, I was gonna struggle with that. Yes, you can sit here and just plug every value in, if I plug in 1 for x, 2 times 1 is 1, minus 3 is -1, and you can continue going that. That just leaves you open to make some possible mistakes. So I have my calculator pulled up here, and that's not the right one. Let's try this one. Yes, so I've got these plugged into y equals. I recommend you doing one at a time just to avoid confusion. I'm going to save time here, so I'm going quick. So I've got the 2x minus 3 plugged into y1. So going to my table, I'm focusing on the y1 column because that's where I plugged the 2x minus 3 into. And I'm just going to fill in those values. Okay, it looks like -4 is at -11. -9, -7, -5, -9, -7, -5. And then following the pattern there, I can anticipate that this is going to be -3. But we always want to double check ourselves because why would we not? And it is. Okay. So then next, checking out the green equation here, that would be the one I plugged into y2, 2/3 x plus 2. You can clear that one out of y1 to make your life easier and less confusing. So there's my table. Okay, because I have to start at 1, I do need to write down and do my best to plot that repeating decimal. But after the repeating decimal, after that first starting point, I can actually skip around a little bit here. So I'm not going to write down the 0.6 repeating. The next one I'm going to write down is the 30. But I did need to write down that one starting point, otherwise it wouldn't line up. We'd have some issues. You'll see what I mean when I say line up. 6, 2, and then let's get at least one more on there. 9, -4. I'm just going to clean this up a little bit. 3, 0, 6, 2, and 9, -4. Boom. Okay, so now I'm going to plot some pieces here. All right, blue equation first. Here we go. 1, -1 is going to be a closed circle, and feel free to either pause or fast forward through this plotting here. Okay, so 1, -1, closed circle, and you will notice the pattern soon. 0, -1, 2, 3, -1, -5. I'm just going down 2 over 1. Boom. So now we have an arrow going in one direction. The arrow on my table is pointing down where the -4 is, meaning it would continue getting negative. So I'm going to make that arrow go this way. Boom. That's one piece of that equation, not the entire thing. It's not the entire line taking up the entire graph, but it's one piece of it. And now for my green one, notice how those 1s are going to line up, but I'm going to be at 1 1/3, which I'm just going to do my best to guesstimate. Open circle. Make sure you can clearly tell that that's an open circle. If you need to, write it in the graph that it's an open, then do so. And then 3, 1, 2, 3, 0, 3, 4, 5, 6, 1, 2. Ooh, just kidding. Was it 2 or was it -2? -2. I didn't write it down correctly. And the reason I knew that it wasn't correct is because if it was +2, that would be going up here, and that is not a straight line, which is what we're dealing with right now. And then 9, -1, 2, 3, 4. Arrow at that end. The arrow would never go this way because then they would overlap, and you don't want to do that. They're always going to be going different directions. And there you have your first piecewise function. So again, we took pieces from each equation and plotted it on the same graph.